All right, in this video, we're going to learn about combustion reactions. By the end of this video, you should be able to predict the products for combustion reactions based on the reactants that you see. So to start off with, how do you identify if a reaction is a combustion reaction or not? It has to do with the reactants. And the reactants for combustion reactions include a hydrocarbon and an oxygen reacting together. Now, the hydrocarbon might not be something that you've seen so far, but the name indicates what elements it's made up of. So a hydrocarbon is a compound that contains both carbon and hydrogen. So looking at examples like these, you'll see that these hydrocarbons contain different proportions of carbon and hydrogen. So the numbers, the subscripts, might be different for the different hydrocarbons, but the fact that they contain carbon and hydrogen should tell you that this is part of a combustion reaction. Now, the reactants for combustion are the same, so you always have a hydrocarbon and an oxygen, but there are two different types of combustion. And the difference between those has to do with the oxygen, which I'll get into. But let's start with complete combustion. So even though you have the hydrocarbon and oxygen, in complete combustion, you have a sufficient amount of oxygen, right? You've got enough oxygen, or in other words, that it's got excess oxygen available. So whenever there is enough oxygen for this reaction to occur with a hydrocarbon, there is carbon dioxide gas produced, as well as water vapor and energy. So let me write the equation out for an example of a complete combustion reaction. And I'm going to use one of those examples that we saw earlier, which was C3H8. This is propane. And propane reacts with oxygen. Now, there are two different scenarios. Again, in complete combustion, there is sufficient amounts of oxygen. So I'm going to express that by writing excess underneath the oxygen. And this is oxygen gas, and this hydrocarbon is gaseous as well. And when there is excess or enough oxygen present, it produces carbon dioxide gas as well as water vapor plus energy. Now, the hydrocarbon might be different in different situations, right? So you might get a different hydrocarbon each time, but it doesn't matter because the products for complete combustion are always carbon dioxide, water vapor, and energy. Now, let's try and balance this out. So to start off with, I've got 3 carbons on the left side, 1 carbon here. So I'm going to put a 3 right there. 8 hydrogens on the left side, just 2 on the right side. So I'm going to put a 4 here. And moving on to oxygen, I've got 2 oxygens on the left side. 3 times 2 is 6 from this, and 4 from here. So 6 plus 4 is 10. How do I make it so that there are 10 oxygens on the left side? I have to put the number 5 right here. So now this is an example of a balanced reaction for a complete combustion reaction. Now, kind of the opposite, we're going to take a look at incomplete combustion. In incomplete combustion, you've got limited or insufficient amounts of oxygen. So there's not enough oxygen available. And in situations like these, you produce not only the products that we saw in complete combustion, but a few extras, and we'll get to that. So let me do the exact same thing that I did previously, where I'm going to write a equation out based off of the example that I'm given here. And for the hydrocarbon, I'm going to use the same one that I did earlier, which is propane, C3H8. And this could be different for the different equations that you might see when doing this practice. Again, you're reacting it with oxygen gas. However, because this is incomplete combustion, it is going to be limited oxygen. And as I mentioned earlier, it does still produce the 2 products that we saw earlier. So it does produce carbon dioxide gas as well as water vapor, and it also produces energy. Now, what makes this different than complete combustion is that there are two additional products. And these additional products, the first one is carbon, solid carbon that's produced, and this is known as soot. And if you're looking at an incomplete combustion taking place in real life, you'll notice a black powder that is produced. That is an indication that this is an incomplete combustion reaction. Now, the second product that's also produced in incomplete combustion is carbon monoxide. This is a very dangerous gas that happens to be odorless. So there's no way of detecting just by looking at it or being there if carbon monoxide is produced. Now, this is why incomplete combustion is dangerous, because it could produce carbon monoxide. And this is why it is not recommended to use propane tanks or propane gas stoves indoors. And that has to do with incomplete combustion, because there is a limited amount of oxygen in a closed space. You run the risk of producing carbon monoxide, which is extremely dangerous and is odorless and very, very deadly. So this is an incomplete combustion reaction. Now, in order to make this a balanced equation, I'm going to, if you want to try and balance this out, pause the video, balance it, and then play so that you can see the answers as I'm taking it up. So in this case, I've got 3 carbons on the left side, 1, 2, 3 carbons on the right side. I seem to be good there. I've got 8 hydrogens on the left side, and I've got 2 hydrogens on the right side. So I'm going to put the number 4 right here so that I can have 8 hydrogens on the right side. And now let's get to oxygens. I've got 2 oxygens here, 4 here. 4 plus 2 is 6, plus 1, 7. So what number times 2 will give me 7 oxygens? And the answer is 3.5. And you'll notice that this might occur in situations where you're balancing a combustion reaction. If you have a decimal as a 0.5, that's totally fine to leave it as is. However, if you wanted to make this into a whole number, what you would have to do is multiply it all out so that you can get rid of this 0.5. Now, this is just optional, but it is good for you to know how to go from ratios that are in 0.5s to whole numbers, right? So I know that if I take this and multiply it by 2, I'll get a whole 7, right? So if I do 3.5 times 2, I'll get 7. Because I'm making that change for the oxygen, not 7.5, I just have to make sure that I'm being consistent for all of the other compounds in this equation as well. So let me show you. So I've got 7, O2 here, CO2 plus H2O gas plus energy plus C plus CO plus C3H8 gas. Now, because I've multiplied this times 2, I'm going to have to multiply all of the coefficients that I have there by 2 as well. So if this is 1, I can write this as a 2. If this is 1, this is going to be 2. This is 4, so this is going to be 8, right? Because I'm multiplying this by 2. Energy stays the same. This has a coefficient of 1, so this is going to be 2. This is a coefficient of 1. This is going to be 2. Okay, so that's how you'd balance in case you're in a situation where you have a decimal place as a coefficient. That's acceptable. It's fine, especially if you have a 0.5, but you can multiply it out to make it a whole number. That's just one example for you to know, just in case you need to know that in the future. All right, and lastly, I know that we mentioned combustion of hydrocarbons, but I also want to address combustion of alcohols. Now, alcohols do contain carbon and hydrogen, but they also contain this OH, right? So they also have an oxygen that's there. So whenever you see a group OH, that's an indication to you that you are looking at an alcohol. And alcohols also undergo combustion in the same exact way. They react with oxygen to produce carbon dioxide and water vapor. Now, if you want to pause the video, you can try and balance it out. I'll just put the answer in here in case you wanted to look at the answer. Yeah, so this is the balanced equation. This is just an example to show you that combustion can also occur with alcohols. But other than that, you should be able to predict the products for combustion, in complete combustion, incomplete combustion, and also for alcohols. All right, that's it.